Preparing for a Azure Data Engineer interview. You've reached Interview Guide, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a modern data lake architecture on Azure? I usually design Azure data lakes around ADLS Gen 2 with layered zones, raw or bronze for ingestion, silver for clean data, and gold for curated analytics. Data Factory handles orchestration, Databricks or Synapse Spark handles transformation, and Synapse SQL serves BI workloads. I secure access through managed identities, RBAC, ACLs, and Key Vault. The key principle is separating storage from compute, so teams can scale processing independently. While answering, focus on ADLS Gen 2, bronze, silver, gold layers, batch and streaming ingestion, governance, security, compute separation, and how Synapse, Databricks, Data Factory, and Purview fit together. Question 2. What is the difference between Azure Data Factory and Azure Synapse pipelines? Azure Data Factory and Synapse pipelines share the same orchestration engine for building data workflows. I use ADF when the project is mainly data integration across many sources and targets. I prefer Synapse pipelines when the solution already lives inside a Synapse workspace and needs tight integration with Spark pools, dedicated SQL pools, or serverless SQL. Functionally, they overlap, so the decision is usually driven by architecture, governance, and operational simplicity. Make sure to cover orchestration similarities, Synapse workspace integration, mapping data flows, linked services, triggers, monitoring, cost considerations, and when you would choose one over the other. Question 3. How do you implement incremental data loading in Azure Data Factory? I implement incremental loads using a watermark strategy. A control table stores the last successful load timestamp, or ID. The pipeline reads that value with a lookup activity, passes it into the source query, copies only new or changed rows, and updates the watermark after successful completion. For reliability, I make the process idempotent and handle late arriving data with overlap windows. This reduces cost and avoids unnecessary full table movement. In your answer, talk about watermark columns, lookup activity, copy activity, control tables, tumbling windows, idempotency, late arriving data, and how to avoid full reloads. Question 4. What are integration runtimes in Azure Data Factory, and when do you use each type? Integration runtime is the compute infrastructure ADF uses to move data or execute activities. I use Azure IR for cloud-to-cloud movement, self-hosted IR when connecting to on-premises or private network sources, and Azure SSIS IR for lifting existing SSIS packages. The important interview point is that IR choice affects connectivity, security, throughput, and cost. For enterprise pipelines, self-hosted IR often becomes critical because many source systems are behind firewalls. Be sure to mention Azure IR, self-hosted IR, Azure SSIS IR, network boundaries, on-premises connectivity, data movement, activity dispatch, and performance or security implications. Question 5. How would you optimize a slow Azure Data Factory pipeline? I start by finding the bottleneck: source extraction, network transfer, sync write, or transformation. In ADF, I tune source queries, enable partitioned copy, increase parallelism, and place the integration runtime close to the data. I prefer columnar formats like Parquet for lake workloads and use staging when loading warehouses. I also check activity run metrics, throttling, and sync constraints. Optimization is not just increasing DIUs, it is removing the slowest link. While answering, cover source query tuning, partitioned copy, parallelism, staging, DIU settings, integration runtime placement, data format choices, retry behavior, monitoring metrics, and bottleneck isolation. Question 6. What is Delta Lake, and why is it commonly used with Azure Databricks? Delta Lake adds reliability features on top of Parquet files in a data lake. I use it in Azure Databricks because it supports ACID transactions, schema enforcement, time travel, and efficient upserts through merge. That makes data lake pipelines behave more like database systems while keeping open storage. It is especially useful for bronze, silver, gold architectures where data is continuously refined. The trade-off is managing optimization, vacuum retention, and file sizes properly. Make sure to cover ACID transactions, schema enforcement, time travel, merge operations, small file management, Parquet Foundation, streaming batch unification, and lakehouse reliability. Question 7. How do you handle schema drift in an Azure data pipeline? Schema drift happens when source columns change without warning. I handle it based on the business impact. For flexible ingestion, I land raw data first and capture metadata. In ADF mapping data flows or Databricks autoloader, I can allow schema evolution for non-breaking additions. For curated layers, I enforce schemas using Data Lake and validation rules. I also alert on unexpected changes because silent schema drift can corrupt downstream reporting. In your answer, include schema evolution, mapping data flows, Databricks autoloader, Delta schema enforcement, validation rules, metadata-driven pipelines, breaking changes, and alerting. Question 8. What is the difference between dedicated SQL pool and serverless SQL pool in Azure Synapse? A dedicated SQL pool is provisioned MPP compute designed for high-performance warehouse workloads with predictable usage. Serverless SQL pool is on demand and queries files directly from the data lake, charging per data processed. I use serverless for exploration, ad hoc analysis, and external lake querying. I use dedicated pools when I need controlled performance, workload management, and strong BI serving. The cost model is the biggest practical difference in real projects. Be sure to compare provisioned versus on-demand compute, storage model, performance, cost, concurrency, external table usage, BI serving, workload predictability, and ideal use cases. Question 9. How would you load large volumes of data into Azure Synapse efficiently? For large Synapse loads, I stage data in ADLS Gen 2 as compressed Parquet or delimited files, and load using copy or polybase instead of row-by-row inserts. I choose proper file sizes so parallel readers work efficiently. After loading, I update statistics and verify distribution skew. For fact tables, hash distribution on a good join key can improve performance. The goal is to feed the MPP engine in parallel, not serialize the ingestion path. While answering, focus on copy command, polybase, staging in ADLS, file sizing, distribution strategy, partitioning, statistics, column store indexes, parallelism, and avoiding row-by-row inserts. Question 10. How do you choose partitioning strategies in Azure Data Lake, Databricks, or Synapse? I choose partitions based on how data is filtered, not just how it arrives. Date partitioning is common because most analytics queries filter by time. I avoid high cardinality partitions like user ID because they create too many folders and small files. In Delta, I combine partitioning with optimize and Z ordering when needed. In Synapse, table partitioning helps manage large fact tables. Good partitioning improves pruning. Bad partitioning creates metadata overhead. Make sure to discuss query access patterns, date-based partitioning, cardinality, partition pruning, small file problems, Synapse table partitions, Delta optimize, and avoiding over-partitioning. Question 11. How do you secure data pipelines and storage in Azure? I secure Azure data platforms using layered controls. Pipelines authenticate with managed identities where possible, and secrets stay in Key Vault, not pipeline parameters. ADLS access uses RBAC for account-level permissions and ACLs for folder-level control. Private endpoints and VNet integration reduce public exposure. Encryption is enabled by default, but I still validate key requirements. Most importantly, I follow least privilege and enable diagnostic logs for auditing and incident investigation. In your answer, cover managed identities, service principals, Key Vault, RBAC, ACLs, private endpoints, VNet integration, encryption, secret rotation, least privilege, and audit logging. Question 12. How would you build a real-time streaming pipeline on Azure? For real-time ingestion, I typically use Event Hubs or IoT Hub as the streaming entry point. Stream Analytics works well for simple SQL-like transformations and windowed aggregations. For complex logic, I prefer Databricks structured streaming, writing to Delta tables with checkpoints. The pipeline lands raw events, processes enriched streams, and serves curated results to Synapse, Power BI, or APIs. I always design for replay, late events, and monitoring lag. Be sure to mention Event Hubs, IoT Hub, Stream Analytics, Databricks Structured Streaming, ADLS, Delta Tables, checkpointing, windowing, exactly once semantics, and downstream serving. Question 13. How do you monitor and troubleshoot Azure Data Factory pipelines in production? In production, I monitor ADF through pipeline run history, activity level logs, and Azure Monitor integration. I send diagnostics to log analytics so teams can query failures, durations, and SLA breaches. For troubleshooting, I inspect input-output JSON, integration runtime health, source errors, and sync throttling. I design pipelines with retries, failure branches, and custom audit tables. Good monitoring should tell me what failed, why it failed, and what data was affected. While answering, include pipeline run history, activity outputs, Azure Monitor, log analytics, alerts, custom logging, retry policies, error handling paths, SLA tracking, and root cause analysis. Question 14. How do you implement CI/CD for Azure Data Engineering projects? I implement CI/CD by keeping ADF, Synapse, Databricks notebooks, SQL scripts, and infrastructure definitions in source control. For Azure resources, I use ARM, Bicep, or Terraform with environment-specific parameters. Azure DevOps or GitHub Actions promotes changes from dev to test to prod. Secrets are referenced from Key Vault, not stored in code. I also include validation steps, smoke tests, and rollback plans because data deployments can break pipelines quietly. Make sure to cover Git integration, ARM or Bicep templates, Azure DevOps pipelines, environment promotion, parameterization, Key Vault references, Databricks notebooks, testing, and rollback strategy. Question 15. How would you design a fault-tolerant and idempotent data pipeline in Azure? A fault-tolerant pipeline assumes failures will happen and makes reruns safe. I use retries for transient errors, checkpoints for streaming jobs, and watermark tables for batch increments. Writes should be atomic where possible, such as delta transactions or staging then swap patterns. I deduplicate using business keys and load timestamps, and send bad records to a quarantine or dead letter path. The core idea is idempotency. Running the same job twice should not corrupt data. In your answer, talk about retries, checkpointing, watermark tables, deduplication, atomic writes, dead letter handling, pipeline reruns, transactional delta operations, and avoiding duplicate records. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.